The next question that was asked about was the quiz question, number 67. We have an equilibrium of water as a gas with sulfur dioxide gas making hydrogen sulfide gas and oxygen gas with a ratio of 2, 2, 2, and 3. We went ahead and set up an equilibrium where we're dealing with an ice chart. 2.8 molar for gaseous water was the initial concentration. 2.6 molar, the initial concentration of sulfur dioxide, and the two products again having a value of 0, and the Kc of 1.3 times 10 to the negative fifth value. So I'm going to just go ahead and push this paper up, kind of set up what we know. If the initial concentrations were given, that was the two values for I in the ice chart for the two reactants, products of course being 0. If the stoichiometry is considered, we're going to let the value of x with the coefficient of 2 reactants get consumed. So 2.8 minus 2x would be the equilibrium concentration of water. 2.6 minus 2x, the equilibrium concentration of sulfur dioxide. Products get made, so we see that those values here are positive. 0 plus 2x, the equilibrium concentration for hydrogen sulfide. And 3 value of x, 3x, for oxygen. The question becomes pretty complex math, and I had set it up just to kind of show where this would lead us. Products over reactants squared, and we start to see that we end up with some equations that end up to be quite complex. And knowing that we end up with something in the fifth power really isn't the quadratic equation formula. So taking the longhand approach obviously doesn't work to get x by itself. So we need to simplify the math, and what we'll do then is assume the 5% rule. So with this particular problem, the polynomial becomes too large, and therefore we're going to simplify. So instead of saying, back up in the original ice chart, instead of saying minus 2x, we're going to assume that that reactant is very small, so therefore we're going to neglect the x. We'll do the same here. We'll neglect the minus 2x for the reactant. So making this in terms of an easier amount, we're assuming that they are significantly not changed, and we'll just toss them out. So then therefore, what we'll end up doing is saying the Kc, 1.3 times 10 to the negative fifth, is equal to the product, which in the value of hydrogen sulfide is 2x, squared, times the concentration of oxygen, which is 3x, squared, set over the concentration of 2.8 squared times the concentration of sulfur dioxide, 2.6 squared. Products over reactants, oh, that oxygen should be cubed. I'm sorry, up there should be cubed. 2x squared times 3x cubed over 2.8 squared and 2.6 squared. We're going to solve for x and then be able to go back and find those equilibrium concentrations. Alrighty. So again, making the ice chart, tossing out the x. I was just going back to read here. They gave us the concentrations and we set it up into an ice chart, and 68 and 69 will be done exactly the same. They're worded the same and asking for the same, so I wondered just to pick up the same answer and do if I get them wrong. A little different, but I think they are the same strategy. So again, toss out the value of x and simplify the math. So we're going to just distribute, see what we get here. 1.3 e negative 5 times 2.8 squared times 2.6 squared, and I'll share my calculator screen. I found a value of 6.89 times 10 to the negative fourth, set equal to, let's see, 2x squared would be 4x squared. 3 cubed is 27x cubed. 4 times 27 is 108x to the fifth. So I'm going to divide both sides by the 108, so 6.89. Second function e negative 4, divide by that 108. Alrighty, so x to the 5th comes out 6.4 times 10 to the negative 6th power. Raise that to the power of 1/5. You want to take the power of 1/5 to isolate the x. Alrighty, and I'll let you continue to hit that and find your answer in the multiple choice quiz. But the trick there was the math got too complex, and we needed to simplify that equilibrium line by tossing out the value of x.